to my channel. In today's video, we're going to be solving the trait challenge in the Starklings.app challenges. Yes. So I just want to briefly go through the definition of trait according to the Cairo book. So it says that trait defines a set of methods that can be implemented by a type. So these methods that can be implemented by a type can be called on the instances of the type when this trait is implemented. So you can liken trait as to interface in Solidity, whereby the interface serves as like a blueprint or a boilerplate, right? Without the logic, it contains all the functions you want your contract to implement, right? And then your contract is the one that contains the logic, right, of that functions, all the functions that was stated in your interface, right? As long as you import the interface, or you want to use the interface in your contract, you have to like implement all the functions in your interface. So it's kind of similar but not exactly, right? So that is a way that you can understand this if you're coming from the Solidity background. So a trait combined with generic types defines functionality a particular type has, yes, and can share with other types, right? We can use traits to define shared behavior in an abstract way. We can use traits bounds to specify that a generic type can be any type that has certain behavior. So note, traits are similar to a feature often called interface, yeah, like I made mention of in other languages, although with some differences. Okay, so let's just jump right into the challenge. So trait one says time to implement some trait. Your task is to implement the trait animal traits for the type animal. This should be a struct, yes. Fill in the input uh, block to make the code work. Yes. So we have come right here. We have the animal struct, which has noise in felt. So that means it's going to be a string, obviously, right? Like noise. We want it to make noise, and then we have the trait that contains the methods of the animal trait. We have function new and function make noise. So we have the input. The input is the one that is going to contain the logic. Is going to contain the logic of this animal trait. So it's the implementation. This is just the method I want it to have, but the implementation of the animal trait is going to be inside this input block, right? So the to do is to implement the trait animal trait for animal. So let me do this. Animal trait for animal. So we have the test. We have another to do here. Make the test pass by creating two instances of animal and calling make noise on them. Make noise is a function from the animal trait. So we just need to like fill this with the implementation, right? We need to fill this with the implementation. So what we are going to do is we need to implement um, the new function and the make function. So we are going to implement the new function to create the animal instance, right, by taking the noise parameter and returning the animal struct without noise. So what do? We do um, function new. It takes in Fel 252, which is noise, right? So this is exactly what we're going to normally. The way I do it is I copy the function from the trait and then put in the implementation. Let me just type it. 252, right? And then it's going to return the struct, the animal struct. Yeah. So what we just basically need to do is to create the animal instance, and then we're just going to insert the noise into it, and that works. Let me give it spacing. Was going to compile which ever way. Okay, so let's go to the other function. The other function is make noise. Make noise is not mutating the states. Make noise, so it's self animal animal, and then it returns well 252, which is the noise that wants the animal to make 252, 252. So what we're just basically going to do is to self dot noise, as simple as ABC. So this is it. Now we need to come here also to make the test pass by creating um two instances of animal and calling make noise on them. So what we're basically going to do here is, as you can see from the assert, we can infer what they want us to do actually from the assert. This assert calls cat dot make noise equals to meow. So we need to actually create like this. Where's cat coming from, cow coming from? So that's what we need to do for the animal instances using the new method from the animal trait. So let's first create the one for the cat to make the noise meow. So we are going to do let cat um, equals animal trait, we are calling the animal trait, right? New, then the meow we want it to make me out. Yeah, works. And then we need to create the variable for cow, animal trait, new, what is that, more. Yeah. So uh this should work just fine. This should work just fine. So we have the cat and the cow. Okay, so let's test. Yes, the code compiled successfully. So let's move to the next. The next exercise says the previous exercise did not make the distinction between different types of animals. Mm, okay, but this one does. So the previous one didn't make the distinction that okay, this is a cow, this is this is a cat, cow cat. Yes. So the trait, animal trait, has two functions: new and make noise. New should return a new instance of the type implementing the trait. Make noise should return the noise the animal makes. The types cat and cow are already defined for you. You need to implement the trait, animal trait, for them. Okay, so let's go through this. Oh yeah. So we have cats, which is a struct, noise, cow noise. So there's a difference now, unlike the previous one that was just animal. So and then we have the animal trait that takes in the generic type, right? And then we have function new, uh, which also returns a generic type. We have function make noise, which returns the noise that is going to be made by the animal, right? We have the impo cat implementation. So that means since we have cat implementation, it's obviously we're going to also have the cow implementation. So implementation, cat implementation of animal traits, cat. It takes in, so the type right here, the generic type right here, the type that's coming right here is the cat, which is instruct. So we're going to have something like that too. We're going to have something like that too. So you can actually understand what we are doing from the definition I we read from the Cairo book, right? So this generic type, but at this point it takes in the cat type of struct. So we have to do implement the animal. Okay, first to do is to implement the trait animal for the type cat. So let's do that first. Let's do that first. So that's, we need to have the new and the make noise. So what we're just going to do is function new, function new is not taking, oh, it's not taking any parameter. It's going to return um so we are implementing the new method to create a cat, a cat, right? Is returning the struct, the cat struct. That means we are going to like add code. Okay, let's check the test. So the test, this is a cat instance, kitty, right? And then it asserts that kitty dot make noise is equals to meow, and then this. So we might just add code the meow noise to make the test pass. So that's what we're going to do. So this is going to be cat, and then we call cat um noise. The cat struct has only one member, and that's noise. So what noise we want it to make? We want it to make meow. Yes, this should work just fine. So for the other function make noise, function make noise is just going to uh return the noise that is being made, right, by the cat. So just going to do this cat, right, and then felt 252. Okay, so what we just do is self dot noise for it to return the noise. So now let's implement the trait animal as well. So we can just do this. We can do this. Lazy developers. So we can just do this and then change it. Cow. Is the type also will be cow. The return struct is, the return type is cow, and then it's going to make The noise is going to make is more, not meow. Also going to be returning this. I think everything is set. Everything is set. Everything is set. So let's test. Yes, our code compiled successfully. So this actually shows, this was quite different from the previous task. So this shows how you can create a generic trait. The generic trait right here is the animal trait, right? And then you can implement it specifically for different types. And different types that we had here was cat and cow. So each implementations provide its own specific behavior, right? I mean, the cat is sounding different and the cow is sounding different. So while they are adhering to the trade contract, they both have the same method, right? So that's just that, and the test pass. So let's move to the last task next. So the last task, trait 3, says the previous exercise showed how to implement a trait for multiple types. Yes, this exercise shows how you can implement multiple traits for a single type. This is useful where you have types that share some common functionality but also have some unique functionality. Okay, so let's go through. We have struct fish with two members, noise and distance. We have dog, noise and distance, and then we have the generic trait, animal trait, which has three methods: new, make, noise, get, distance, right? And then we have fish traits. um okay, so those are the multiple traits we have: animal trait, fish trait, dog trait. We have three different traits. So the fish trait has the swim method, the dog trait has the walk method, and we have the implementation, the fish implementation. So the fish implementation is creating the instance for the fish here, and the distance is writing to the fish struct. Right, make noise returns the noise, and get distance also returns the distance. The animal dog implementation to if you notice, the dog trait has walk in it, right? And then we have animal dog implementation of animal trait, which takes in the dog type. And then we have function new, we have function make noise from the animal trait, yes, and function get distance. We are not even making use of the dog trait. Yes, so you can see it says of animal trait, so it's not of dog trait, right? So our to do is to implement fish trait for the type fish trait for the type fish, and then implement dog trait, okay, for the type dog. Okay, so let us get started. Implement fish trait for type impo fish impo. That's to be capital I. Fish impo of fish traits of fish traits And then we're going to the fish trait only has one method if yes, that's swim. So FN swim, it takes in the fish, the fish um fish, right? And then okay, it returns implicitly. Okay, okay. So what do we want to do here? Let's go to let's check the assertions. So we have salmon fish, salmon dot swim, assert salmon dot make noise is equals to blob, salmon dot get distance is equals to one, long distance. Okay, so from this we can see that when the swim function is called right here, right, it increments the distance of the fish by one, right, and then it also returns the noise the fish makes, and that happens for the dog walk as well. So what we basically need to do, okay, we already have the ref set to modify the struct in place. The fish struct has to have distance then. Okay, yes, it does. So what we basically need to do is to do self dots. We are calling distance, right, from the fish struct, and then we want to increment it equals to one. Okay, so let's do that same thing for the dog. Let's see what is going to dog. Dog is walking. Dog traits. It takes in a walk and the dog type, not fish this time. So this should work. So when the dog the dog method was called, the walk method was called on the dog here, and then this should work. It increments by one and then makes this noise. Okay. Um, so a fish can swim and increment its distance. Where is this swimming? Blob. Okay. Yes, yes, this is it. This is where it's happening, where the blob is being written to, and the dog as well. Okay, yes, yes, yes. So this should work just fine. This should work just fine. Yes, our code compiled successfully. And so this has bring us to the end of the trade challenge, right? In the next video, we are going to be solving the dict, and we